me puedo acercar.
Hi, everybody. Let's see. So, thank you for joining us at Oracle OpenWorld, and I'm going to talk about two different new products that we've developed at Oracle. And today I'm going to focus on our brand new database, the latest version of Oracle 18c, which is the world's first autonomous database, and I'll explain what I mean by that. And I'll be talking primarily about that. But I'm also going to be introducing the Tuesday topic on highly automated cybersecurity, because believe it or not, the two are closely related. People think of cybersecurity with a variety of threats. I mean, there could be a denial of service attack that makes it unable for you to sell tickets. You can't sell tickets to the coming concert for an hour. Well, no one ever got called before Congress because they were unable to sell tickets to a concert for an hour. People got called before Congress because data was stolen. So let me be very clear about the biggest threat by far in cybersecurity is data theft. And data theft is all about, or preventing data theft, is all about securing your data and wherever you choose to store your data. And we're going to try to make a strong case today that the safest place for you to store your data is in an Oracle database, specifically an autonomous Oracle database. I'm going to explain, and I'm going to spend a lot of time explaining why, but these two things are together. We developed them together. They're based on the same underlying technology. And they work together to prevent data theft. They are both highly, highly automated. That means we do everything we possibly can to avoid human intervention. They're robotic. They're autonomous. It's our computers versus their computers in cyber warfare. And we have to have a lot better computer systems, a lot more automation if we're going to defend our data. Now again, I said today I'm going to focus on the autonomous database. But I'm going to introduce our highly automated cybersecurity product that I'm going to talk about in detail on Tuesday. And the key thing that you have to do in cybersecurity is know when you're being attacked. And you need to know early when you're being attacked. You have to know during the reconnaissance phase of a cyber attack, when someone's kind of nosing around in your computer systems, trying to steal a password, trying to assume someone else's identity. And as they come in and start looking around, you'd better detect that's happening during that reconnaissance phase. Because after the reconnaissance phase, they infiltrate your systems, and eventually the goal is to take your data and send it someplace else. If it's a commercial actor, your data will be for sale on the dark web. If it's a state actor, who knows what they're going to do with your data? We can guess. We actually know a lot about what certain state actors have done with data they've stolen from the United States government. Anyway, the cybersecurity technology is designed to automatically detect threats when they first occur, and then direct the database to immediately remediate that problem. So the cybersecurity system identifies a threat and then says, all right, we have to combat this threat. So it might mean we have to patch the database. And the database system has to be able to immediately patch itself, automatically patch itself. not wait for a human being to schedule downtime where there's an opportunity to gracefully implement a patch in a month or two. By the way, which was what normally happens. The worst data thefts in history have occurred after a patch was available to prevent the theft. The patches just weren't applied. How is that possible? Well, in order to apply a patch, typically you have to bring your systems down. No one likes to bring their systems down. It's called scheduled downtime. So you either have to proactively schedule emergency downtime or wait for the next scheduled downtime and then apply the patch if the human beings think it's important enough. Anyway, it's a human process. It relies on scheduling database downtime, lack of availability of the system. There's a lot of approvals up and down the chain that have to occur. That doesn't work. Doesn't work. Didn't work at Equifax. Didn't work at the Office of Personnel Management. Doesn't work. Doesn't work. We have to automate our cyber defenses. And you have to be able to defend yourself without having to take all your computer systems offline or shut down your databases. So, the database, after it's been notified by the security system to remediate the problem, the database has to be able to patch itself immediately while running. So these two things are closely related. No delay, no human intervention. Has to happen immediately. By the way, this is one critical benefit of running an autonomous database, but there are plenty of other benefits as well. Okay, our new security system and our new autonomous database system are based on the same underlying technology. And that technology is every bit as revolutionary as the internet itself. And it's called machine learning. Kind of a branch of artificial intelligence. For years and years and years, artificial intelligence did not live up to its promise. But there is a new type of AI. No, I didn't press the button. I don't know why they let me do this. Wait, no, go back. Go back. Go back. It's good. See, what they do, all my button does is notify a human being. It's really not automation at all. It's fake automation. If it was real automation, that would not have happened. Okay. So all of this, I'm going to move my thumb so it's not touching that green button. So it's based on this new fantastic technology called machine learning, which really is, if you will, the first branch of artificial intelligence that really, really works. Next slide, please. Okay, I'm going to put this down and just do it that way. All right. Now, you don't have to understand the details of machine learning to understand that this is a dramatic and revolutionary new technology. Now, I don't use the word revolutionary new technology every year here at our OpenWorld. We don't, because there aren't that many revolutionary new technologies. But this one is. And you can recognize them simply by the charisma of the applications they enable. Completely autonomous vehicles. You get in the car and tell it where you want to go, and there's not even a steering wheel. It just drives itself. Totally autonomous. Now, autonomous is very different than highly automated. My jet airplane is highly automated. I'm a pilot, but I still have to take off. I still have to land. There's an autopilot that does lots of things for me, but it's highly automated but not autonomous. Self-driving cars, fully autonomous, enabled by machine learning technology. Computer vision. Computers now can recognize a face better than human beings can. Human beings are more likely to mistake one person for another than a computer. There are cities in China right now where they recognize every single person who's about to cross the street. There are cameras everywhere. They know everybody in that city, where they are, and whether they crossed on a red light or a green light. This technology is what we used to fully automate our database and partially automate our cybersecurity. But make no mistake, we are headed towards full autonomy in cybersecurity as well. Next slide. Now, I'm not going to give you a long tutorial on machine learning. I think that would be a bad idea. But it is relatively, the high-level stuff is relatively easy to understand. It's computers, it's based on computers looking at lots and lots of data and finding normal patterns in the data and distinguishing normal patterns in the data from abnormal patterns in the data. And in fact, there might be several versions of normal, and that's called clustering. So you've got a group, you've got, for example, you might be looking at human cells. And you might say, oh, that's really an abnormal cell. Oh, there's another one that looks just like it. Oh, those are neurons. Neurons look very different than other cells. That's one cluster of normal cells. And then there are hepatic cells, liver cells. And there are all of these other cells, blood cells. But then, having trained on all of this data, you can detect a real anomaly. Again, the more data you look at, the better the more training. The system learns. The computer learns by looking at more and more and more data. And eventually, you can say neuron normal, hepatic cell normal, skin cell normal, blood cell normal. Oh my God, that is not a normal cell. That is an anomaly in the data. This is not right. This is a cancer cell. Or you can detect that your CFO has just logged on at 3 a.m. to your financial systems from the Ukraine. Which is fine if you're a Ukrainian company, I guess. But if you're like a California retailer, that is probably not a good thing. So, next slide, please. Now, the good news is there's enormous amounts of computer data that we collect and store. And tremendous amounts being produced every day, billions of records being produced every day, and all of these event logs that we have. And we have, the hardware has event logs, records the event. The storage systems, the hardware, the network, the operating system, the VM, they're all logging all of this information. The database, someone logs on, someone creates a table, someone issues a query. Each and every time that happens, that's logged. And if the computer studies all of that information, it can figure out what a normal log-on looks like, and what an outlier looks like, what an anomaly looks like. And by taking all of this log data and unifying it, and training the computer to understand normal patterns from abnormal patterns, we're able to detect that it is highly abnormal for your CFO to have logged on from the Ukraine through an IP address hidden by Tor. Of course, it takes a while to figure out what's the Ukraine, because Tor's whole purpose is to prevent you from knowing that what the real IP address is and what the real location came from. But you detect that too. You can detect every log on it that goes through Tor. By the way, we don't want to just collect information about anomalous events. We want to look at, detect certain normal patterns. And by looking at certain normal patterns, we're able to automatically tune the Oracle database. No human, and we can tune it continuously. We can constantly be looking. Query patterns could change. Data distributions could change. The size of the database could change. All of that could change. And we constantly adapt and tune the system without human intervention. This is a big deal, by the way. No one else does this. Next slide. What I said earlier, the database, fully autonomous, 100% automated, automatically provisions itself, patches itself, updates itself, tunes itself, backs itself up without any human intervention whatsoever. Fully autonomous. Cybersecurity, highly automated. Still some human intervention, but more and more and more we're moving to full autonomy there as well. By the way, there are lots and lots of other benefits to database automation beyond cybersecurity. Next slide, please. Okay. Oracle 18c, the latest version of our database, is the world's first and only fully autonomous database. This is the most important thing we have done in a long, long time. Next slide. All right. If you eliminate human labor, you eliminate human error. There's two reasons. By the way, it's always embarrassing to me to admit this, but my autopilot flies my plane a lot better than I do. It just can't do everything. In this case, the automation does everything. You get into the plane, you tell it where you want to go, and it flies you there. There is no pilot error anymore, because there is no pilot. All of the database administration is fully automated. Therefore, we can guarantee an availability time of 99.995%. That's less than 30 minutes a year of planned or unplanned downtime. And you say, well, I've seen other people who claim, 4 nines, 5 nines, things like that. Yeah, well, read the fine print. Read the fine print carefully. They specifically exclude unplanned downtime due to maintenance, unplanned downtimes due to software bugs, unplanned downtime due to configuration changes, unplanned downtime, or planned downtime for that matter, due to security patches. They just exclude all of that. They basically exclude all reasons you have downtime and then say we're never down. They might as well claim to say 100% availability, because everything else is excluded. This is everything. Planned, unplanned downtime. You are down less than 30 minutes a year with the Oracle Autonomous Database. The other thing that's interesting, because it runs itself and it tunes itself, it's very efficient with the use of computer resources. It's elastic in its use of computer resources. So if you need more capacity, more compute capacity to run a big query, it allocates, it goes from, let's say, 8 processors to 16 processors to run that query, then drops immediately back to 8. And it does that while it's running. It's fully elastic. Now, I know it's called the Amazon Elastic Compute Cloud. It's just not elastic. In other words, Amazon's database Redshift cannot automatically increase the number of processors to run a bigger workload and then free up those processors. Just can't do it. And one of my demonstrations will show that they're unable, it's not an elastic system. You have to shut the system down, allocate entirely new, twice as much hardware over here, copy the database over into the new storage, run it, then copy the database back to the old one, shut the new one down and run that. It is not elastic. This thing is truly elastic, instantaneously elastic. So you never provision more resource than you need. It really is on-demand computing. When you need the resource, you add the processor capacity, you add the storage capacity, you use it, and then you give it up. And you're only billed for what you use. Truly elastic. Amazon can't do that. In fact, no one can do that. Azure can't do that. No one can do that. Therefore, we're able to guarantee that you take an Oracle workload, run it on Amazon, take an Oracle workload and run it on Oracle. We can guarantee our bill will be less than half of what Amazon would charge you. You take a Redshift Amazon database workload that's already running at Amazon and you move it to the Oracle Autonomous Database, and we will guarantee in writing, contractually, before looking at the workload, that any of those Redshift workloads will move to Oracle and your bill will be 1/2 or less than what Amazon charges you. We will write that in your contract. You better be sure about this. You guys. Next slide, please. By the way, the database has lots of other really cool new features. I mean, 18C is not, by the way, that's the year, 2018, even though it's out in December 2017. It's kind of like a car model, you know. So it's out early. The Oracle Autonomous Data Warehouse happens to be available in December, but it's still called version 18C. And it has lots of cool stuff. I mean, it's got, we've sped up rack 5 times. So if you have a rack workload with a good deal of messaging going back between the nodes, it's much faster. We're all ready for non-volatile. You know, we put caches, certain caches in non-volatile memory, non-volatile RAM. We have a much faster. We ingest streams of data twice as fast as we used to. There is a variety of really cool things in addition to a lot of automation that's gone into 18C. So, but I'm not going to talk about those. That's it. It's my only slide on other features other than automation. Next slide. When you need an Oracle database that's fully fault tolerant, that will survive a disaster recovery like a flood in Houston that knocked out every data center in Houston. That's not what happened, by the way. That's it. If you had 2 data centers backing each other up in Houston and they both fail, no problem, because the way we have disaster recovery in another location. So if you're doing data processing in Phoenix, on one of our 3 data centers in Phoenix, all connected by a fiber optic ring, and all 3 data centers are lost for whatever act of God that could cause that. You have a copy of that database in Virginia, and it's fully recovered. That's a fairly complicated configuration. Plus, you have active data guard in Virginia. You have rack in Phoenix. It's a complex configuration. You do that with a press of a button. You simply say, I want rack and I want disaster recovery, and that's it. We configure this and provision the system for you automatically. You don't do anything. You just say the policy. I want fault tolerant, node fault tolerance, and I want disaster recovery, and it's done. It configures it and provisions it automatically. The system then after it provisions itself, it then manages itself. It expands and gets additional resources and gives them up by itself. It patches itself, backs itself up, tunes itself, all while running, all without any downtime whatsoever. and where there's no human administration, there's no human error, and some of these data heists are inside jobs. So there's no human error and there's no opportunity for human malicious behavior. Next slide. Again, a little repetition. Human beings tune the database, then it goes production. And things change rapidly. The database gets larger. Data distributions change. Lots of people add new queries to the application. Human beings periodically come back and tune the database, sometimes once a year, sometimes twice a year. We retune the database continuously. That's why it's going to be way better than a system that's tuned and use a lot more resources than a system, a lot less resources than a system that is tuned by human beings. It's continuously tuned by the computer system itself. Next slide. Resource elasticity, no downtime. We'll demonstrate that. You cannot do this with Amazon. Typically, what people do when they go and configure a system, whether they're buying it for on-premise or they're buying it at AWS, is they configure more capacity than they actually need. Because it's kind of a pain to go back and get the additional capacity just in time. Well, this is just-in-time capacity planning, or capacity delivery just in time. You don't allocate compute, you don't allocate storage until you're actually going to use it. There's no overpaying for partially used configurations, and it minimizes your expenses when running the database. Next slide. All right, there's a lot of things, to have 99995 reliability and availability. There are a lot of things we have to do. One thing, things fail, things break. Hardware breaks. There are software bugs. There are a bunch of things there's regularly scheduled maintenance. We have to take part of the configuration down. The rest of the configuration has to keep on running. So, in the case of a compute node failure in a rack system, as you know, let's say you have 4 nodes running the rack database, 4 separate nodes. One fails, okay, you run a little bit slower, but it's still available, and you can bring the other node back online, fix the other node and bring it back online. The system is never unavailable if you have rack. Most databases don't have anything like rack. They don't have fault tolerance. When they're running on one node, and if you have to, that node goes down, the system is down. If you have to patch that node, you got to take that node down. Interesting thing with rack is we can do rolling upgrades. Again, let's say you got 4 nodes, 4 computers, if you will, running rack, and we're patching it. How does that work? How can you change the code while it's running? Surely that's not possible. Of course it is. We have 4 nodes, but you still have to start with something like rack. You got 4 nodes running rack. You quiesce one of the 4 nodes. You apply the patch. You add it back into the cluster. You quiesce. Quiesce just means stop. Fancy computer world means stop. You stop it. I don't know why I ever use that word. Quiesce. Not exactly stop. It's a little slightly different, nuanced stop. Anyway, you stop another node. Upgrade that. You go through that rolling upgrade, and you fix the thing. You use a similar technology for major database upgrades. Major upgrades we can handle while still running. I mean, you've got to have this technology. I mean, there aren't a lot of databases that have this technology. Certainly not the databases at Amazon. So we can do major release upgrades. We can patch while it's running. patch it while it's running. If there's a regional, if Phoenix goes out and you have active data guard running over Virginia, just not a problem. You keep running. So you have to tolerate failures. You have to deal with some failures. And then you have to be able to remediate things like software bugs without taking the system down. They're slightly different, but they're, again, it's all related. This is a lot of technology that you need to be able to do something that sounds as simple as patch the database while it's running. It's not simple, but that's what we do, and that's what we totally automate. We even handle user errors, where a user accidentally deletes a lot of your data. We have this thing called flashback queries, where we can recover your data that was deleted yesterday. We can recover the data that's deleted. There are a lot of these things that we have. No one else has this stuff. We've been working on this for a very, very long time. And now we've reached the point where the system is totally automated, and you get to take advantage of all of this and get incredibly high degrees of availability and performance. But the shock is, you have to be willing to pay much less. And I'll show you, all of this stuff, it costs a fraction of what Redshift costs at Amazon, or a fraction of what other databases cost in other clouds. Next slide, please. All right. I mentioned this. If you read Amazon's guarantees, availability guarantees, they're not exactly, it's not exactly 99.995. Next slide. Next slide. Okay, back it up. Back it up. All right. There are all of these, again, Amazon has all of these exceptions to their availability guarantee. We have no exceptions to our availability guarantee. If it's down for any reason, it's counted in that 30-minute budget we have for downtime. Next slide. All right, the autonomous database is available in December for data warehousing applications. There are two broad classifications of database applications. One is online transaction processing, the other is data warehousing. And the OLTP version of the autonomous database comes out in June of next year. It's delivered production June of next year. You can start playing with it before that. But the production version of the autonomous database for data warehousing is out this December, very soon. Again, completely automated, incredibly efficient, and unprecedentedly reliable. Next slide. Now, the Oracle Autonomous Database happens to run on Exadata infrastructure, and it's available. It's available in our public cloud on Exadata, and but it's also available in cloud at customer.
Keeping it down.
So we make it available on premise. If the customer wants to put their data behind their own firewall, and that's what you prefer, and it's available in our public cloud. It's available both places. Next slide. And it's really very attractively priced. Last week we introduced our bring your own license to our PaaS pricing. It used to be you could just bring an existing Oracle database license and carry it in and then run it on top of our infrastructure as a service, or for that matter, Amazon's infrastructure as a service. But if you wanted to use kind of our highly automated PaaS services, those you rented separately. There was really no ability to take an existing database license or middleware license or analytics license and use that and apply that as a credit to the purchase of PaaS services, just infrastructure services. Well, we changed that last week, and we came out with bring your own license to PaaS pricing. which has dramatically lowered the cost of using PaaS. So all the price comparisons I'm going to show you in these coming demos are based on our bring your own license to PaaS. And you'll see that there's two kinds, and PaaS pricing for database. This is database PaaS pricing, but actually all PaaS pricing is the same. This is kind of like for all of our PaaS services. That BYOL cost for compute and standard infrastructure is $168 per CPU, and it is $250 for Exadata infrastructure, CPU. Basically $148 per terabyte per month. By the way, that's $280 per CPU per month and $148 per terabyte per month. Those are the Exadata infrastructure prices, and those are the ones we use in the cost performance demos I'm about to run. We use them. This is what's called the pay-as-you-go pricing. So this is, you use services and we bill you every month for the services you use. If you're an enterprise, you will probably choose some level of monthly commitment and get a substantial discount off of the pay-as-you-go pricing. So you'll say I'm buying $10,000 a month or $20,000, whatever it is, and we're using that monthly commit pricing and the standard 30% discount that goes with the monthly commit pricing. Also, the bring your own license, what's required for the fully autonomous database, and bring your own license, it's the enterprise edition of the database. As you saw, it requires rack, and it requires the new multi-tenant option. And if you want 4 nines and a 5 availability, you have to also have disaster recovery. So you need Active Data Guard. So if you want the full availability, 4 nines and a 5, you need disaster recovery. If you don't need that quite that good, then you can do it with just rack and multi-tenancy. Next slide, please. But by the way, back that up again. But this is cheap. By the way, the entry level, you only need 1 CPU and 1 terabyte to get started. With the 30% discount, you can run the Oracle Autonomous Database Data Warehouse for $300 a month. This is not expensive. There's not a high entry level price to get started on Exadata. It's Exadata infrastructure, it's Exadata storage. You can start with 1 CPU, 1 terabyte a month. The 30% discount, that's a few pennies less than $300 per month. Next slide. There's an autonomous service that we are working on for many things. Certainly the data warehouse, our OLTP database, the Express version of Oracle, and our NoSQL key value store are all going to full autonomy next year. All of that is fully autonomous next year. By the way, and the PaaS pricing applies, the new PaaS pricing that I just showed you applies to middleware, it applies to analytics. Bring your own license to PaaS applies to all of our PaaS services, not just database, but also middleware, also analytics. These are dramatic price reductions. Next slide, please. And I'm going to get a bottle of water. It's right here. Okay, in June, the OLTP version, and this is very interesting. When you provision the system, you can say, I want a mission critical system. I'm done, mission critical. Fully rack, fault tolerant, active data guard, disaster recovery, and what you've said is, I want mission critical. I want higher performance. We'll add nodes. Or you can say, oh, this is test dev. I want the lowest cost system you can configure. And we'll automatically provision the lowest cost OLTP system for test and development. You just have to tell us your policy. What's your policy? Well, this is mission critical production. This is test dev. We automatically provision and will optimize either around low cost or high performance and availability. That's all you have to tell us. We do the rest. It's fully automated, self-driving database. Same thing, as you need more capacity, it automatically expands. When it's not using the capacity, it gives it back so you don't pay for it. And it's available except for 30 minutes a year. No exceptions. Next slide. Next slide, please. Okay, the NoSQL database, key value store, again, delivered in a fully autonomous fashion, both in the, and this is the, oh, by the way, available cloud to customer, available in the public cloud, available next year, fully autonomous version, fully, highly reliable version. Next slide, please. This slide is for the people who say, oh my God, you're automating away the job of database professionals. What are we going to do? Well, no database professionals are saying that because database professionals have more work than they can possibly ever get to. It's not like they're looking for things to do, sitting around. By automating a lot of this is going to free up a lot of the DB professionals to get away from routine, things like routine patching or checking the backups, doing things like that, the day-to-day administration, which is very important. Don't get me wrong, this will be automated in December. But you'll see a migration and evolution of database skills where you're focused more on database design, schema design, different kinds of data analytics, including machine learning, setting the policies as to what is mission critical, what requires disaster recovery, figuring out what what those policies, authorization, who's allowed to see the data, who's not allowed to see the data, and when, all of those kinds of things, and just a lot more time securing your data because this problem is getting a lot worse. I know it's again, it's a little bit of a shock, but there was a patch available for Equifax because somebody didn't apply it. I don't know where the CEO lost their job, which doesn't bother me now, I'm not CEO. I mean, that's a risky job those guys have. Two guys in the front row. So, but no, I'd lose my job too. I mean, it's a clean sweep. Directors aren't safe. Nobody's safe when something like that happens. You start at the top and you just start brooming away. This is going to get a lot worse. People are going to get better at stealing data. We have to get better at protecting it. And a lot of effort, a lot of work. We see a lot of our database professionals spending time in the SOC, in the Security Operations Center, and making sure that that data is not being exfiltrated to the Ukraine. I know I'm picking on Ukraine, but any place it shouldn't go. Next slide. Okay, I've got 6 short demos. I'm actually going to run just a couple of the demos. I'm going to show you the slides on the other demos because I don't keep you here for until midnight. But these are fairly short demos. We cut them way down. And the first 3 demos shows the Oracle Autonomous Database, the Oracle Autonomous Data Warehouse, against the Oracle data in the Oracle Cloud versus the Oracle database in the Amazon Cloud. So it's kind of like Oracle on Oracle versus Oracle on Amazon. So let's look at the first slide. Okay. Amazon has a database service they call RDS. It's their highest level Oracle service that they offer at AWS. But it's completely manual. You manually upgrade, you manually patch, you manually tune. If if you've got human pilots, there's going to be some pilot error no matter how good the people are. And whenever you patch, whenever you upgrade, you've got to have downtime. They don't have rack. They don't have active data guard. They don't have a lot of these database features at Amazon that we rely on for the autonomous database. They don't elastically get more resource and then give up the resource. You configure to the high water mark, and that's all you can do. And you may not use it, but that's what you got to pay for. And it's not fault tolerant. They don't have, again, blah 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 blah. Next slide. That was the other slide I was looking for. Seriously, you've got to read section 61 of your Amazon contract. It includes downtime for adding compute and storage capacity. It excludes, okay, so I think Amazon guarantees how many nines? 3 nines? 99.9? Amazon includes 99.9 reliability and availability, except there are certain exclusions. Like it doesn't count when you're down for any reason. The easiest way to describe section 61 of their contract. It doesn't include downtime for adding computer storage capacity. It does not include downtime for Amazon maintenance. It doesn't include downtime for your maintenance. It doesn't include downtime for patching your software, or database upgrades, or database patches. It doesn't include downtime for regional outages. And certainly doesn't cover downtime if there's a bug. And on and on. I mean, it's actually funny. They might as well guarantee 100% and just make the exclusion list a little bit longer and they're done. Next slide. Okay, so we ran these benchmarks, and I remember in the old days when we ran the first Exadata benchmarks, and no one believed them because it came back we're 10 times faster, 50 times faster. That's ridiculous. Those guys, they mean they're 10% faster, 50% faster. No, we actually meant, but no one believed us. And then we said, I remember saying, when you run Oracle at the Oracle cloud, it runs way faster than the Amazon cloud. And they said, well, who cares? Amazon's cheap. I mean, I'm there to save money. I mean, you guys are Mercedes. You guys charge a lot, and they give me this really good deal. We're going to soon find out. So, our configuration for Oracle in the Oracle cloud is not even our latest Exadata. It's Exadata, but it's Exadata X6, not X7. I wanted to use X7. These guys used X6. What can I tell you? They're trying to be fair. They're trying to give Amazon a break here in these comparisons. By the way, X7 is a lot faster than X6, and we would have looked even better. We did just fine, by the way. We did fine. Our pricing is exactly what I said on the other slide. It's our bring your own life PaaS pricing with a monthly commit. So it's our PaaS pricing at a 30% discount. Amazon, we used similar size configurations and their standard pricing with their standard discounts. We did exactly, and we compared. Again, there are two sets of tests. One is Oracle on Oracle versus Oracle on Amazon. And the second three tests are Oracle on Oracle, or the Oracle Autonomous Database, versus Redshift on Amazon. So we have 6 demos. Next slide. And by the way, these are real customer workloads. These are not, Oracle went out and made up the most ridiculous demos to make Amazon look bad they could come up with. These are data sets that we actually use for stress testing and performance testing and validating our database. So our customers give us lots of databases that they want us to test their workloads, and we took these specific databases, these 4 databases and these 4 workloads to test. So this is in no way